4.2, logarithmic functions and their graphs. How would I evaluate this? F of x equals log base 2 of x, where x equals 32. How do you evaluate that? How can I rewrite it? You're not evaluating it in your calculator.
I got you.
Okay, what?
You put 32 where the F should be, right?
No.
Look
Come
at
on.
it for x.
You what?
Wait.
Look at it for x.
Plug it in for x?
Yeah, that.
No. Oh, you mean like plug this in right here?
Yeah.
So that says log base 2 of 32.
Don't you carry the log over to the other side?
So what does that mean? If I have
2 on the other side.
It changes, not log, it's something else with an L.
no,
Ln.
ln, stop. Ln and e go together. Natural log and the natural base of log is e. Log goes with what base? 10. Okay, but that's not what I'm doing here because I want to know log base 2 of 32 equals what? So you need to rewrite this into exponential form.
Wait a minute, can't you just put the, put you, oh, never mind,
What were you asking, Cameron?
never mind, you already did it.
Okay, so I need to rewrite this so that I can solve. I basically need to say 2 to what power gives me 32? What? 5, that's your answer. That's solving this one, 5. Okay, how would you rewrite this one?
0.
If I put 1 in here, right? Log 3 of 1, that means I'm saying 3 to what power equals,
1.
and Talia said it's 0. Okay? And when I plug this into x here, I get log base 10 of 1 over 100. So I'm saying 10 to what power equals 1/100th?
Negative
100.
1. Negative 10.
No, stop. Remember, if you have 10 to the 10th power, that's going to give you a very large number.
Oh, negative 2.
Negative 2. Because when I have 10 squared, I get 100. So negative 2. So this is the first thing that you're going to do on your homework tonight. You're evaluating by putting it back into exponential form so you can ask yourself the question, what to this power gives me this? Okay? This is all done by hand. We can't do it in the calculator. So you have to rearrange it and you have to know math facts. Yes.
Wait, so for B, why is that 0?
Because anything to the 0 power gives me 1.
Oh.
It's just a logarithmic rule. Okay? Then we're going to come to a section where it does say use a calculator. Why can I use a calculator here, but not in this case over here?
Because they were 10.
Because they weren't 10, because my bases weren't 10 here. Okay, well, technically I could here, but my bases weren't 10. Here, my base is 10, so I can use a calculator. Okay? So here, I'm plugging 10 in for x, correct?
Mm-hmm.
So plug it into your calculator. Log base 10 of 10, what do you get?
Wait, how do you do that?
Remember, if you just hit log,
1.
it is already got a base of 10 in it, so you don't have to put that in. So just do log 10.
Oh.
1.
1. Okay, 1. What is log base 10 of 1/3?
Negative 0.477.
Negative 0.477.
Mm-hmm.
Okay, what is log base 10 of negative 2?
Non-real answer.
Non-real answer, is that what it says?
Yes. Syntax error.
Syntax error is what it says. Beautiful, there should be an error there. Why is there an error there?
You
Can't have a negative.
Yes.
No solution.
Okay, no solution, error, I don't care, write either down. Okay, so that's the second part of what you're doing on your homework, plugging it into your calculator with log.
I'm hungry.
I am
The
too.
third part of your homework is we're going to try to remember log rules. I did not write the log rules up here because I want to see how, if we can work through them to remember them. Okay, log base 2 of x equals log base 2 of 3. What does x equal?
3,
Why, Cameron?
because.
The big number goes in front of it.
Yeah, thanks,
Wait, they're equal to each other and they look the same.
thanks.
If they're equal to each other and the
Cameron.
bases are the same,
Yeah.
if they're equal to each other and the bases are the same, I can drop the log part and x equals 3. or whatever's on this side equals whatever's on that side. So if this said 3x plus 12, and this said 2x, they would be set equal to each other, okay? What about this rule here, log base 4 of 4 equals x? Log base 4 of 4 equals x, what do you do there? Log base 4 of 4
Oh,
equals x, what would
what
x
is last
equal?
I gotta think. The one.
It is 1. It is 1. When you have a base,
Oh, yeah.
and it's raised, and when the base and the,
Base and then the X is.
yes, is the same, it's x equals 1. Because basically, if I rewrote this, it would say 4 to what power equals 4, right?
Oh.
That's what this is saying, 4 to what power equals 4 if I rewrite it.
Is the stuff we learned last year?
It is stuff we learned last year, that's why I was testing you out. Okay? Log base 5 of 5 to the x. Log base 5 of 5 to the x, what do I get there?
-1.
No, man, not negative 1.
1.
Log base 5 of 5 to the x. This one's a little bit trickier.
1.
So basically, it would be saying,
Error.
No. no, basically, if we rewrote it, it'd be saying 5 to what power equals 5 to the x power, correct? Okay? So, if you have, so it's gonna be this. Basically, if we rewrote it, it would say 5 to the x power equals 5, to what power? So it would end up being just x as your answer. When the base and this are the same and it's raised to a power, all you get is what the power was as your solution. Okay, this one's the easiest one. What do you do? 7 log base 7 of 14.
Two.
Huh? Don't divide anything. No, what happens to 7 and log base 7?
Cancel.
They cancel.
14. Boom. I'm smart.
They cancel and you get 14 as your answer. Okay, those are the 4 rules. These are inverse property rules, and these 2 are just logarithmic rules that you're going to have to apply tonight in your homework.
What's that?
I don't know.
That doesn't
Now,
exist.
let's graph these equations in the same viewing window. I will not make you sketch any of these by hand tonight when it says that,
Amen.
okay? So how would I set these up in my calculator to actually graph them? On the first one, can I just plug 2 to the x in?
Mm-hmm.
Yes. In the second one, can I plug log base 2 of x in?
Probably not.
Probably not.
You gotta probably plug in a number for it, you know what I'm saying?
You have to probably
One.
plug in what?
-2, -1, 0.
No,
1, 2.
I told you, we're doing this without plugging in numbers. So
Oh,
I,
I'm sorry, okay.
so I can plug this into my graphing calculator just like it is. Why can I not plug this into my calculator the way it is? Well, it has a log, but what base is the log?
It's not 10.
It's 2, it's not 10, correct?
You gotta make it equal to.
Why does it have to be 10?
Because that's the only thing your calculator reads, is a
So
log
put
base 10.
Log 2 to the 5th.
No, Tally.
This cost me $120.
How can I change this? How can I change this so that I
Put a big
can?
2 in front of it.
Talia, no.
So then they cancel out.
A big 2 in front of
Yeah,
it.
like, so
Like
they
the
cancel
7
out.
and the 7. And then the
Yeah,
answer
like
just
You
be
can put a
X.
log and keep the X.
Because.
How are you gonna graph f of x equals
No,
X?
listen.
If the log is
If I rearrange this, right, it would say 2 to what power gives me x, correct? If I rearrange it in exponential form, 2 to what power gives me x? What is this right here?
A 2.
But how does this compare to this?
It says
Same.
equals X.
It's the same, except
Oh,
this has a log in front of it down here, yes?
Yeah.
So what are those 2 equations gonna be?
The same.
If one has a log with it, and one is in exponential form, they are opposites, they are inverse functions of each other. So if I graph the top one, that means the bottom one is going to do what?
Flip.
Flip. But when I'm dealing with logarithmic functions, it flips over y equals x. So when I graph this,
Oh, what do you want our viewing window to be set?
you can set standard.
Oh, dang, bro, you went to the L?
You can set it in standard form on this one.
Well, they racing.
What's going on?
Negative 10, 10, 1, negative 10, 10, 1. Sit down, Tyler.
They're
So when I
racing.
graph this one, this right here is 2 to the x.
Oh, that's not the way.
When I have a logarithmic function, when I have a power and logarithmic
Flips over
function,
the x-axis.
it then reflects it over x equals y, which is this diagonal
The
axis.
z, is that an asymptote or no?
Yes,
Okay.
okay, so it's going to flip it over that. So then all the points become opposite, so it's going to go like this. Let me think if I can draw this because I'm not visually good. It's gonna come here, and it's gonna go opposite.
I'm not visually good either.
I'm not visually good at this stuff. So flips it over. Now, I could put this into my calculator by using change of base. Change of base is where I do big over small, yes? So you would have log x over 2, big over small. And if you put that into your graphing calculator, log x divided by 2,
Told you you had to put it over two.
you should get it to
Okay.
flip. It does flip. It just looks weird on mine.
So how did you get the B into the calculator again?
How do you get this part? You use
got
change
it.
of base formula.
Okay.
So if I take the large number over top of the small number and use a natural base, or use a log base 10, I can plug that in.
Got
So you
you.
just put log and then x over two.
Yeah.
X over whatever value.
And that's how you can get it into your calculator. You use change of base. Okay?
It doesn't look the same.
It does, it's just cut off, that's why. Because it's gonna ride this line down.
Going right the line.
Okay. Now, let's talk about using a calculator to evaluate this. This should be simple. How do I evaluate these functions when x equals 2? What do you put in your calculator?
Two.
Two.
Okay, what's ln 2?
0.69.
And what is ln negative 1?
Error.
Yeah.
Error?
Yeah.
Why?
Because you can't have a negative.
Good. So, error, no solution. And then what's ln 1 plus radical 2?
0.88.
Oh my land, so we have
Point
to do what?
88.1.
0.88. 0.88, okay.
Point 88.
So those should be easy for you to do tonight. Now, we're gonna use the same properties to rewrite the expressions of natural log as we did with the
I already
log
forgot.
base 10.
Is that just E?
It is just, yes, see that's gonna be our difference. We're gonna have to change things into E, yes.
Isn't O-N E?
ln does represent E. So how do I rewrite this? ln 1 over E.
Question.
Yes, what?
I don't understand how ln can represent E when they're both in the same equation.
If, okay, so you know how log has a base of 10? Natural log's base is E. So can log base 10 be in the same equation?
Yes.
Yes, so natural log base E can be
Multiply
in the
each
same
side
equation.
by E and they cancel out so you get more.
No, we have to rewrite this. We have to say E
Times 1 over E.
to what power, right, gives you 1 over E. How would you do that? What power would change it to flip it to 1 over E?
Negative 1.
Negative 1.
Oh, look at me
you.
go. I know, right?
Okay? What happens in the second one? What happens when you have E to the natural log of 5? What happens there?
This equals 5.
It just equals 5. Why, Cam? Because they're the same. E and natural log are the same, so you get 5. It cancels it out. Just like down here, when I have log 4, 4, it's the same thing cancels. Well, log 5, 5 cancels. Okay? 4 natural log of 1. How do I rewrite that, or how do I solve that? 4 natural log of 1.
Plug it in. Sarah.
How do I fix that one? 4 natural log of 1.
Wait a minute.
What happens
If
when
you
I have
have
natural
Log
log of 1?
and then
Zero.
0.
Yes,
because
so
it's
you
like
have
having
this.
that.
So when you have natural log of 1, this turns into a 0, so you have 4 times 0, which is,
Oh, I told you it was 0.
When did you say that?
I said
Yeah, I'm pretty sure.
Did you hear me?
Oh, is that what you
Oops,
said?
sorry.
I didn't know what you were saying
Cat,
there.
cat, cat.
Okay, 2 natural log of e. What happens there? 2 natural log of e. What happens when you have natural log and e together? What do they cancel out?
Two.
No, natural log and e don't cancel out. They make
One.
1.
So 2.
So yes, so you get 2 times 1, which is 2.
Two.
I is smart.
But I
Now,
said first.
Last part is finding domain of things. Finding domain. I know you hate finding domain, but this isn't actually that bad. Okay, find the domain of natural log x minus 2.
2.
Sort of, yes.
Plus or minus 2.
No, 2 is like where the cutoff is, right? Does it continue forever, or what does it do?
Less than or greater,
Yeah.
equal to something.
You guys are
Yes,
very my
so you're gonna take whatever this is every time, and you're going to set it, greater than 0, yes? Greater than?
Wait,
Yes.
isn't it greater than or equal to?
No, just greater than, because this is an absolute value. This isn't an inequality. This is log
Okay.
and natural log. So add 2 to this side, and you get x is greater than 2. So the way I would write this is I would say 2 and I would say infinity, yes?
2 infinity.
And I use parentheses because x is only greater than 2, it's not greater than or equal to 2. What do I do down here?
What about the ln?
I'm not
You're only
worried,
finding the
I'm just
domain.
finding the domain right now, I don't need the natural. What about b? How would I set that one up? The same, 2 minus x is greater than 0, subtract 2, right? Negative x is greater than negative 2, divide by negative 1, and x
X is
is,
greater than 2.
no, what happens when I
X
divide
is
by
less
negative?
than 2.
There we go, negative, less than 2, yes. So then, if it's less than 2, it should be negative infinity to 2.
Oh my gosh. I'm so thoroughly perplexed.
And what do I do at the bottom one? Natural log of x squared.
Plug it in. To your calculator.
No, I'm not gonna change anything, I'm gonna take x squared and I'm gonna set it greater than.
Or equal to 0.
Why do you keep throwing equal to?
I mean, greater, I don't know. It's an accident.
Really do that.
So x is greater than 0. So when I go to write that, it's really all real numbers except for 0 in this case, because I would write it, if I wrote it in this notation, it would be negative infinity to 0, and then it would be unified 0 to infinity. Okay? That is what we're doing tonight.
Oh my goodness. I'm so.